So we did questions like this last year, where we multiplied, we divided, we raised one power to another power, and these are all the rules. So like if I said this, what's that? Well, divide the coefficients, divide the numbers in front. What do you get? -3. Now, what is x to the 7th divide x squared? X to the 5th. We did tons of these last year, and we reviewed them this year. Now, what we're going to do is instead of just whole number exponents, we're going to add fractions and negative exponents. But the rules don't change. They're still the same. When you multiply powers, you add the exponents. When you divide powers, you subtract the exponents. When you raise one power to another power, you multiply the exponents. Those are the three main ones. Except there's one thing we have to follow. After we finish a question, we can't have any negative exponents in our answer. Okay? So any negative exponents we have to change to positive. Let's just look at some examples. What do I do with the exponents here? Sorry? Add them. So it's going to be x to the -3 plus 6. What is next? What is -3 plus 6? All right. 3. No negative exponents in my answer. We're done. Not too bad. When I divide these two, base stays the same. What do I do with the exponents? Subtract. So it's going to be 3 subtract 5, which gives me y to the -2. But I can't leave my answer like that. I have to write it as a positive exponent. Well, it doesn't matter whether this is a number or a variable. How do I write this as a positive exponent? 2. What do I do with the base? Flip it. What's the reciprocal of y? 1/1. And this is just the same as 1/y squared. So whenever you get a negative exponent in your answer, just make sure to change it to positive. We don't multiply the 7s because they're the bases. So the base stays the same. What do I do with the exponents? Add them. So what is -3 plus -4? -7. But I can't, just let me finish this one, but I can't leave my answer with the negative exponent. So how do I write this using a positive? 1/7 to the positive 7. Or 1, because 1 to the 7th is 1, over 7 to the 7th. Yes?
When you're doing this, why don't you multiply?
Because those are the basics. We never multiply the bases. I think you're confusing this with something like this. Here, we would multiply the 7s because the 7s aren't the bases. The x's are the bases. We wouldn't multiply the x's by each other. We keep the x's the same. Here, the bases are 7, so they stay the same. Okay? Okay, this one you're going to watch out for. Base stays the same. When I divide, what do I do with the exponents? What do I do with the exponents? When I divide, what do I do with the exponents? What? Subtract, Nikki. Now, but watch out for this, because it's not 2 minus 4. It's 2 subtract negative 4. You've got to watch out for that. Which means this changes to what? 2 plus 4, which is, are there any negative exponents I have to change? No, we're done. When I raise one power to another, base always stays the same, no matter what exponent law I use. What do I do with the exponents here? Multiply. And what is 3 times negative 2? Negative 6. How do I write that using a positive exponent? You should be able to see the pattern now, you guys. How would you write it using a positive exponent? Yeah, flip the base to what? 1 over x to the positive 6. I don't have to write a 6 up top because 1 to the 6 is still 1. So I just skip this step. Okay? Looks a little complicated, but don't let it throw you. What do I do with the base? What happens to the base? No, I'm going to do the exponent law first. I'm not going to do the negative exponent. When I raise one power to another power, what happens to the base? I keep saying this over and over. The base stays the same. 2 over 5. What do I do with the exponents? Multiply. So I get 2 over 5 to the what? Negative 6. Which, how do I write using a positive exponent?
5 over 2 to the positive 6.
5 over 2 to the positive 6. Perfect. Okay. So those were sort of straightforward ones. Which we'll still keep doing. Okay. Okay. What happens to the base? Stays the same. What do I do with the exponents? Multiply. Y to the 12. Do I have to change any negative exponents? Nope. Done. Yeah.
When we're writing the answer for a test, we have to show the steps. Already know where
Like, do you have to show this? No. You can go straight to this. Yeah, that's with the same thing. Yeah. Oh, okay. Now we got to multiply the x's together, and then we got to multiply the y's together. So what do we get, Olivia?
It would be x to the negative 1 and y to the negative 2 over 1. And if you flip it, so it would be 1 to the xy.
Yes. Does everybody see this?
No. I thought it was 5. Yeah, wait, because are you multiplying?
Negative 3. No, because we're multiplying the powers, so we add them. Right? It's not like this. X to the negative 3 times x squared, we go negative 3 plus 2, which is negative 1. And then we go 2 plus negative 4, which is negative 2.
Why are we doing 2x?
Sorry?
Why are we doing 2x? Am I confusing that?
Because the base stays the same. It doesn't change. You get it. Okay, and then,
One over x, y to the two.
right, so if you look at this, if I write this as a negative exponent, it's 1 over x to the first. I just flip the base, make the exponent positive. This is 1 over y squared. Well, together, if I multiply them, I get 1 over x y squared. There's actually a quicker way we can do that, which I'm going to show you in the next example. When we divide, what do we get? Divide the coefficients, what do we get? 5.
And then the.
A to the third, B to the, watch out for this one. Does everybody see that it's B to the fifth because you have to go 3 minus -2? Okay, this means 3 minus -2, which gives me positive 5. Any negative exponents to change? Nope. Remember, if this 5 was negative, we don't change it because it's not an exponent. Okay. We're back to multiplying again. Remember, if there's no exponents, put a 1 with it. So -7 times -3?
21.
21. X to the first times x to the -4th.
X to the negative third.
Add those two. 1 plus -4 is -3. Y to the first times y to the first. Y to the second. Now, here's where you can take a bit of a shortcut. I can't have a negative exponent, can I? What did we always do? Didn't we always move the power down? Like when we flipped it, we moved it down. So all I have to do, you don't have to worry about writing 1 over x to the third. Just do it like this. 21 y squared, they stay up top. To make this positive, I've got to move it down into a denominator. So I just do that. And I'm done. Right? To make that positive, I got to flip the base. So when I flip this, the x actually goes down into a fraction in the denominator. That's a quick way you can do it. Okay. We're back to raising powers to a power. Well, first of all, let's do the coefficient. 3 squared. 3 squared.
9.
9. Okay, because there's no exponent with the 3, so I just do 3 squared. What do I do with the exponents with x?
X to the negative 10.
Multiply them to get x to the -10. What do I do with the y's? To get y to the
8.
right. I can't leave my answer with this. So what does my final answer look like?
Over and what's that x to the 10?
Perfect. Well done. This last one is a bit of an interesting one. What is x to the first to the negative second? Multiply the exponents. What do you get?
Y to the 2.
X. X to the negative 2. Right? On the bottom, y to the first to the negative second. What do I get?
Y to the negative 2.
Y to the negative 2. Now notice, this is weird. I've got a fraction with a negative exponent up top and a negative exponent on the bottom. How do you move it? Move this one down. What do you think you do with this one? Move it up. If it's down and negative, move it up in the fraction. If it's up and negative, move it down. So we're just going to switch these two. So when I move the y to the negative second up top, I get y to the second. When I move to the x to the negative second to the bottom, I get positive 2 as an exponent. And I'm going to stop there right now, okay? Because I think it's important that you get some practice with this on your own now. How to know which exponent law to use, how to change any negative exponents to positive. Okay? Tomorrow we'll start looking